In this video, I'm going to talk about the curl and divergence. But before we can talk about the curl and divergence, let's talk about the del operator. Okay, the del operator kind of being this upside down triangle, and we should already know that we have the del operator being it's a vector, right? So it's this operator that gets applied. So you get that plus j d dy plus k d dz. All right, and you could write this as, right, so the del operator is this vector, right, that gets applied to a function. All right, so we normally, what we had done is we'd apply it to f, right? So we'd have this gradient vector, right? Because then f becomes this vector, right? So the gradient vector of f are these partial f with respect to x, partial f with respect to y, and partial f with respect to z. All right, and again, this here is your gradient, or your gradient vector, right? So let's use this del operator in two different ways. One we're going to apply for the divergence, and one we're going to apply it in a way for a curl. So first of all, we're thinking of this f, this vector f, right? This vector f as a fluid is a fluid or gas flow. All right, so some sort of velocity flow vector field, and we want to compute two quantities that describe the way this vector field curves. One will be curl, one will be divergent. So let's look at both kind of at the same time here. So we have divergence, and we have curl. So in this video, I'm not going to go into detail about what these particular instances mean, but what we are just looking at here is how that vector field curls, and how for divergence, basically the way the vector field moves away or towards any particular point. So it's this tendency, this fluid, the tendency for the fluid to move or compress or move away from itself. So these two things talk about basically, all right, so they talk about, so divergence and curl explain how a field curves. Just a general word here, curves. How it curves, one way or the other. So how we're going to do that, we're going to calculate that by using this del operator on that vector field, right? So we're going to use it in two different ways. Okay, so for the curl, right? For the curl, okay, we're going to just put del del here and a del here, all right, for curl and divergence. So for the divergence, we're going to use the dot product. So we're going to have the del, and we're going to apply it to f. Okay, so we're going to apply it. We can kind of state this as well. We'll apply it to f like that, and then for the curl, we're going to apply it through a cross product. So it's for the divergence, you've got curl dot your P, your Q, and your R. Again, well, you know that dot product is going to give you a scalar quantity. So when you do this dot product, and you can definitely see this in chapter 16.5, you can look at this, but this is going to give you this addition of the partial P with respect to X, and then partial Q with respect to Y, and partial R with respect to Z. Now we're going to apply, for the curl, we're going to apply the del through a cross product. And you can just write that as cross P of F, the vector field. All right, and then we end up with, all right, so this is a cross product. So you go ahead and do the cross product, and you're going to end up with, R, Y, QZ, PZ, minus RK, or RX, and QX minus PY. Alright, so you'll see here, for the curl, you've got this vector field that you produce, and for the divergence, you're getting the scalar function. One last thing, when we calculate divergence, we're going to really use that for the Gauss's divergence theorem coming up, and for the curl, we're going to be using that for the Stokes theorem, which is coming up as well in the course.